The story of Dr. O continued, as Dr. O has discovered in consultation with the computer scientist in her research group, data cleaning is one of the many problems that have been classified as NP-complete. But luckily, in this case, there is more to the story. In fact, there is the perspective of this book. Progress since Gary and Johnson on the data cleaning, aka vertex cover problem, has unfolded in the following way. In 1986, Fellows and Langston observed that the powerful Robertson-Seymour graph minors theory can be invoked with no effort to conclude that for each fixed value of k, the k-vertex cover problem can be solved in time big O of f of k times n to the third, where n is the number of data points. More about this very powerful and mathematically exciting complexity classification machinery can be found in Chapter 7. The fact that this result concerning vertex cover as news at all reflects, perhaps, a kind of a neglect of this sort of question. How well can we do when k is fixed? In 1987, Johnson observed that an big O of f of k times n squared algorithm for k-vertex cover could be based on a combination of tree decomposition and finite state dynamic programming techniques. More about these general methods can be found in Chapter 6. In 1988, Fellows gave an algorithm for the k-vertex cover problem with a running time of big O of 2 to the k times n based on a search tree technique. This simple but important idea is described in Chapter 3. In 1989, S-Bus described an algorithm with a running time big O of k times n plus 2 to the k times k to the 2k plus 2, based on the method of reduction to a problem kernel described in Chapter 3. This was developed as a general method by Downey and Fellows. In 1992, by combining the ideas R. Balasubramanian, R. Downey, and Fellows and V. Raman, reported. In R. Balasubramanian and Fellows and V. Raman described an improved algorithm with running time big O of k times n plus 2 to the k times k squared. In 1993, Papadimitriou and Yannakakis used maximum matching as a subroutine in an algorithm with running time big O of 3 to the k times n, and observed that these yields a polynomial time algorithm for vertex cover whenever k is big O of log n. In the context of computational biology, this algorithm was rediscovered by Bonnet et al. In 1998. In 1996, Balasubramanian et al. Described an algorithm with a running time big O of k times n plus 4/3 to the k times k squared, based on a combination and refinement of previous techniques. Thanks to this development, Dr. O finds that data cleaning problem has a good practical algorithm for data sets of any size, so long as the number k of bad points is no more than about 70.